Hi everyone. So far, you might have studied what an operating system does, like process management, memory management, file systems, and scheduling. But today, we are going to understand something more fundamental, how an operating system is internally structured. This internal structure is called operating system architectures. Just like how a building needs a strong architectural design to stand properly, an operating system also needs a clear architectural design to work efficiently, securely, and reliability. First, let's discuss on what is OS architecture. So, an operating system architecture describes how the OS is internally organized, how the different OS components interact with each other, how OS communicates with hardware. It answers questions like where does the memory management code run? How does a user program access hardware safely? How are OS services divided internally? So the OS architecture is not about features, it is about design philosophy. A well-designed architecture decides a performance, security, reliability, and scalability. Why? Why do we need OS architecture? Because now imagine an OS without a proper architecture. All code is mixed together, like device drivers, file systems, memory managers, and process schedule. What happens? It is difficult to debug. One small error can crash the whole system. Very hard to modify or upgrade. So OS architecture is needed for manage hardware resource efficiently, provide abstractions to users and applications, ensure protection and security, improves system reliability, and simplify OS development and maintenance. Without architectures, the operating systems become unmanageable. The core principles of operating system architecture. Before looking at different architecture, we must understand the principles behind them. Every operating system architecture is built based on certain design principles such as abstraction, modularity, separation of policy and mechanism, protection and security, efficiency and scalability. Let us understand each one slowly and clearly. First, the abstraction means hiding hardware complexity from the user and application. For example, you don't directly access RAM locations, you don't control CPU registers manually, you don't handle the disk sectors yourself. Instead, OS provide logical abstractions like processors, file, and virtual memory. Think of abstractions like this: when you drive a car, you use steering, accelerator, brake. You don't control pistons or fuel injections directly. Similarly, the operating systems allows the programmers to work at higher level without worrying about hardware details. This makes programming easier, safer, and less error prone. Modularity. The modularity means dividing the OS into separate functional units. Each module handles a specific task. One module for memory management, one module for process scheduling, one module for file systems, one module for device drivers. Why is this important? Because errors can be isolated, modules can be tested independently, upgrades are easier. If a printer driver fails, the entire OS should not fail. So modularity improves maintainability, reliability, and development speed. This is a very important design principle. Policy versus mechanism. This is one of the most exam important concepts. Policy decides what should be done. Mechanism decides how it should be done. Example for policy: which process should get CPU first? Mechanism: context switching code. Why separate them? Because the policy can change, mechanism usually remains same. If they are separated, OS becomes flexible, easy to modify scheduling strategies, easy to support different system requirements. Good operating system architectures always keeps policy separate from mechanism. Protection and security. Deep explanation about this. Operating systems must protect hardware, OS itself, other user programs. This is done using dual mode operations, user mode and kernel mode. User mode runs in user mode with restricted access. Critical OS code runs in kernel mode. If a user program tries to access hardware directly, modify the OS memory, the OS operating system blocks. This prevents accidental crashes, malicious attacks. So the operating system architectures plays a major role in system security. The next one is abstraction and modularity. We have discussed right now. Abstraction hides hardware complexity, provides logical view, modularity, everything. The policy versus mechanism that we have discussed. Policy is what to do, mechanism is how to do. Protection, user mode and kernel mode, controller access to the resources. Next, we discuss about monolithic OS architecture. Now, let us talk about the actual types of operating system architectures. First, we'll discuss with monolithic architecture. In the design, the entire operating system runs as one large program. All services run in a kernel mode. Components communicates directly between them. The main advantages of monolithic operating system is very fast execution. There is no communication overheads. But the disadvantages, it is difficult to maintain. One bug can crash the entire system. Poor fault isolation. So the example of monolithic operating system architecture is early Unix systems followed this architecture. The next one is layered operating system architectures. In this layered operating system architecture, the operating system is divided into multiple layers. Each layer provides services to the layer above it. The bottom layer is the hardware. The top layer is user interface. The main advantages of this layered operating system architecture is we have the clear structure. We can easily debug the errors and easy understanding of the process. The disadvantages is the performance overhead, extra delay due to layer crossings. The layered architecture focuses more on clarity than speed. The next we're going to discuss on microkernel architectures. So the microkernel architecture follows a different idea. One only essential features run in this kernel: process management, memory management, inter-process communication. Other services run in user space, that is file systems and device drivers run in user systems. Advantages is high reliability, better fault isolation, strong security. The disadvantage is communication overhead between the models. Microkernels are widely used in real-time operating systems and safe critical critical systems. Generally, the microkernel architecture is used in real-time operating systems where the all the codes are placed inside the chip. The next one is modular and hybrid architectures. So the modern operating systems use the hybrid approaches. The modular architecture is the one which employs that. The core kernel with loadable modules. Modules can be added or removed dynamically. Example, the Linux operating system. So hybrid architectures which combines the monolithic speed with microkernel reliability. So the main advantages of the hybrid architecture is the performance as well as the reliability. The examples of hybrid architecture is Windows Y operating systems and Mac operating system. This gives the best of both things. And if you compare the OS architectures, we have different types of architectures: monolithic, layered, microkernel, and hybrid architectures. If you compare the performance, reliability, and flexibility, the monolithic has high performance, but it is less reliable and flexible. The layered architecture, it shows the medium performance, reliability, and flexibility over other OS architectures. The microkernel has the low performance, but it has high reliability and flexibility. If you consider the hybrid architectures, which provides high performance, high reliability, and high flexibility. So the operating system architecture defines how OS is structured, how components interact, how performance and securities are achieved. Thank you.